So this is an introduction to inverse trigonometric functions. Now these are the inverse of sine, cosine, and tangent. Now, as we know about inverses is that we have to have one-to-one functions, meaning they have to be functions after you invert them. That is, reflect them over the line y equals x. Now if you look at this, this fails the horizontal line test because, well, it's repeatedly going to hit that. So what that means is we have to restrict the domain. Now we try to restrict the domain in such ways that we can retain all the possible values of sine, right? That is as high as 1 and as low as -1. So what we do is we actually restrict it to a domain of -pi/2 to pi/2, okay? And that way, when we actually then reflect it over the line y equals x, which remember is, approximately this line here, we end up with a function, and I know this is going to look like a bit of a mess, but it's going to look something like this. The reflection over that line, right? So that being said, the key thing that we need to take away from this is that we really need to only look at this portion of the graph in order for it to be invertible, okay? So that means if we're looking at sine x, we have a domain restriction from -pi/2 to pi/2 inclusive, and a range, well, the range would be from -1 to 1. That way it covers all the possible values. And that way that the inverse, well, the range would be from -1 to 1, and the domain would be from -pi/2 to pi/2. We'll talk about the practical import of that here in a sec. Now cosine is a little bit different. In order to actually make sure we get all its values, if we were restricted from -pi/2 to pi/2, it would still be not invertible. So what we do there is we actually look from 0 out to pi/2 pi. So if we look at this piece of this graph, right, this piece right here, that is actually invertible. So what it means is we restrict the domain for cosine from 0 to pi such that it has a range, once again, from -1 to 1. That is all the possible values for the output of cosine. Now tangent, because we have this repeat of this graph, it would seem pretty obvious that we just want to end up with one of these pieces. Now remember, tangent with how it's constructed didn't follow very well. That means just this piece. Tangent, how it's constructed, is undefined, and it has asymptotes at pi/2 and -pi/2. So what we end up with is a domain restriction for tangent from -pi/2 to pi/2, and then a range that ends up being, well, in this case, because tangent is different, it can heads off to positive infinity. Same here. So what we end up with is -infinity to infinity. Oops, that should be non-inclusive though, right? Infinity never stops. So what it means is the inverse functions have very specified domains and ranges. Okay, what this means. Because they're inverse, the output is an angle measure given a value of the sine, cosine, or tangent. So given a value between -1 and 1 for sine or cosine, or positive or negative infinity for tangent, okay, that's important to remember, we're going to get some sort of angle measure. Now, depending on how it's defined, it may be something that falls out on the unit circle, like, well, we're going to take a look, but it's some angle on the given on the unit circle. Because they're all otherwise invertible, the domain sine, cosine, and tangent must be restricted, which we saw, which means the domain and range of the inverse function is also restricted. The inverse is written using the -1 exponent, so like sine inverse or sine to the -1, right, like this. And that's something you've seen before. Or we use arc sine. These are the same thing, by the way. So if they sine the inverse of x, that's the same as arc sine of x, just another way of writing it. And Desmos will actually take arc sine, which is handy because it's easier to type arc sine than it is, for instance, sine inverse. So remember, these domain and range restrictions are very important. So these are just for the inverse functions. It means that if you're the domain, that is, if you're taking the cosine inverse or arc cosine, it has to be a number between -1 and 1 inclusive, and then it's going to generate a number between 0 and pi. So the important thing to remember is about the inverse functions is it's going to give results that are, in the case of cosine, between 0 and pi, in the case of sine and tangent, it's going to be between -pi/2 and pi/2, okay? That means you're not going to get values that cover the whole unit circle, all right? So let's take a look at some examples. So the arc cosine of -1/2. Now, the arc cosine means that you're looking for this x value, the angle associated. So when you're looking at arc cosine, if you look, there are actually two values where the x is a negative, and that would be at either 2 pi/3 or 4 pi/3. Now, the thing about arc cosine is we're not going to get all the possible values. In fact, because remember the arc cosine has an output that is between 0 and pi, we're actually only going to get 2 pi/3 as our answer, okay? So remember, it's important to remember for arc cosine, the outputs are going to be between 0 and pi, okay? So in other words, quadrant 1 and quadrant 2. Now the arc sine of pi/2. Remember, this has to be between -1 and 1. Well, -1/2 is, right? What is pi? Pi is the same as saying about 3.14. So this is the arc sine of 3.14/2, which is around 1.57. So it turns out that this does not exist. This is not possible, okay? Because this falls outside of the domain of the inverse. So be on the lookout for that too. Sometimes you can't get an answer. All right, the arc tangent of -√3/2. Actually, that should be -√3/3. My bad. So this you have to do a little bit of thinking. How do we get -√3/3? So if you think about how tangent is calculated, it must have come from, because it's sine over cosine, this. Because remember, this ends up being 1/√3, which we rationalize to √3/3, right? So -√3/2. That means one of these has to be positive, one has to be negative, okay? So remember, this means that the sine is, the y value is going to have to be 1/2, and the cosine is going to have to be √3/2, but one of them is going to have to be negative. Now remember, for arc tangent, you're going to get values between -pi/2 and pi/2. So you only have these two quadrants, quadrant 1 and quadrant 4, to look at. Now hopefully it's obvious you must be in quadrant 4, where the x's are positive and the y's are negative. So that means that the sine must be -1/2 and the cosine must be √3/2. So there's only one angle there, and that is 11 pi/6. But you're not going to get that answer. You're actually going to get an angle measure, because if you look on the unit circle, it's going to be 11 pi/6 right over here. That's actually, if you think about the corresponding reference angle, that's pi/6 right there, right? That would mean that this angle is actually -pi/6, okay? So when you're getting values or writing what the arctan is or whatever the inverse is, you have to remember that's going to generate between -pi/2 and pi/2 as your answers for sine and tangent, or 0 and pi for cosine.